Consider this. What if software could be transformed into formulas and vice versa? It's a question that might seem more at home in a theoretical mathematics course than a programming tutorial, but today, it's the cutting edge of software development. Welcome to the future where software equals formulas. The concept we're exploring is bidirectionality. It's a term borrowed from mathematics, but in the world of programming, it takes on a whole new dimension. It's the idea that every program can be transformed into a formula and every formula into a program. Take a simple function, for example. You might be familiar with fx, return x plus x. It's a straightforward piece of code that takes an input x and returns the value of x added to itself. But what if we look at this function not as code, but as a formula? We can represent it as sxy, equals sign y equals sign x plus x. Suddenly our function is no longer just a piece of software, it's a mathematical equation. But why does this matter? Well, it all comes down to logic. Software at its core is logic. It's a series of instructions that tell a computer what to do. But when we represent software as formulas, we're not just telling the computer what to do, we're explaining why it should do it. And that opens up a whole new world of possibilities. This is where the magic of bidirectionality comes in. With a tool like an MSO solver or any second-order logic solver, we can take our formula sxy, equals sign y equals sign x plus x, and feed it into the solver. The solver doesn't just evaluate the formula, it interprets it. It understands the logic behind it. Given a specific input x, it can evaluate fx. But it can also do the reverse. Given fx, it can figure out what the original input x was. This two-way street, this bidirectionality, is the key to a process called program synthesis. Program synthesis is the idea that we can use logic formulas to not only define the behavior of a program, but also to generate or invert programs based on logical specifications. It's a dynamic, flexible approach to software development that could revolutionize the way we create and understand programs. So, what have we learned today? We've explored the concept of bidirectionality, the idea that software can be represented as formulas, and that these formulas can in turn be transformed back into software. We've seen how logic solvers can interpret and invert these formulas, paving the way for program synthesis. And we've discussed the potential of this approach to transform the future of software development. In the end, it all comes back to that initial question. What if software could be transformed into formulas and vice versa? As we've seen, the answer is much more than a theoretical possibility. It's a reality that's changing the world of software development as we know it. And it's all encapsulated in one simple yet powerful equation: software equals formulas.